Okay, there we go. So this one, whoa, how many x-intercepts do we see here? Just the one, right? Well, we can have less than 5, we just can't have more than 5. Okay, so we've got one x-intercept, but how many changes of directions do we have? 1, 2, 3, 4. Isn't that what we said it would have? Alright, great. So what I want you guys to do now is to just fill in this rest. You don't have to graph this, but I want you to say for number 2, how many x-intercepts can this have? How many changes of direction can it have? Do the same for 4. It should take you about 30 seconds. Alright, let's go to Ryan. Tell me on number 2. What do we learn from this one? What is a degree? So what does that mean? You have up to 2 x-intercepts. You could have less, but that's okay. What about changes of directions? Yeah. Or turning points is what we've been calling them. Turning points. Awesome. Emma, I'm going to have you help me out for the next one. What is our degree? What does that mean? Nice. Thanks, Emma. Thanks, Brian. Is this okay, guys? I hope this is pretty basic. It's going to get a little bit trickier as we keep going, but if you just keep those things in mind, we're good. Now, who remembers what we call this form that it's written in right now when it's all multiplied out like that? What form is that? That is standard form. Good job. So standard form makes it really easy to figure out the shape because you can see the degree, you can see the leading coefficient, so you know if it's going to be an S or a U. You can also figure out how many x-intercepts or turning points you could expect to have. However, we're going to be looking now about intercept form. What do you think is easy to figure out when it's in intercept form? Don't think too hard. The intercepts. What? Okay. Let me just talk about this graph or this page for a quick second, and then we'll get back into that intercept one. So this one, it just says, without graphing, determine the number of zeros for each of the polynomials. This would be really quick. How many roots do we, so what's the degree here? How many x-intercepts do we expect? Up to 4. How many turning points? 3. That's it. This one, degree is 5. How many intercepts do we expect? Up to 5. How many turning points? Up to 4. Okay, you get the idea, right? Okay, now let's talk more about those x-intercepts, okay? And we're going to learn about something called multiplicity. Now, I want you to add this up there. So multiplicity, let's define it. This is how many times an intercept is used. And it might not make sense right now, but after we get through this, you'll be like, oh, that makes sense. All right. Here are polynomials, and they're all in intercept form. Intercept form makes it easy to figure out the intercepts. Good job. Now, the intercepts are going to be whatever makes these parentheses become 0. what value of x could I plug in to turn this into 0? And it's the opposite, the negative 1. Yeah, see, negative 1 plus 1 is 0. Another word for intercepts is zeros because it's the values that make it become 0. So one of my zeros or one of my intercepts here is negative 1. Now, what would make this second parenthesis turn to 0? 2 minus 2 is 0, so 2 is another intercept. Right here, what value plus 4 gives me 0? So when I graph f of x, which I'm going to let this one be f of x, and I apologize that the graphs are teeny tiny for you guys. Just do your best. I was trying to save paper here. But we're going to have 3 x-intercepts. We have negative 1, 2, and negative 4. Negative 1 is right here. 2 is right here. And negative 4 is right here. Okay, now what I want you to do is actually I want you to graph this on Desmos, and then we'll talk about why it looks the way that it does. You're going to Desmos, and you're going to graph x plus 1 times x plus minus 2 times x plus 4. And if anyone's having any computer issues, let me know so I can try to help you out. Doesn't match with what we got. Alright, if your buddy needs help, help your buddy. But what I think is going to happen is that it's going to start like this. Whoa, that's such bad noise. Sorry. Alright, now, is that what yours kind of looks like? Rough sketch, not perfect, but is that what yours looks like? What shape does that look like? Like, what, is that odd or even? Odd, okay. Now let's talk about a couple of things. First off, what happened at the x-intercepts? It just went through the x-intercepts, right? No problems there. What was the multiplicity for each of those? How many times was each intercept used? Well, if you look at the exponent, nothing's written, but there's really a 1 there. So it was only used 1 time. So what happens at an x-intercept when the multiplicity is 1? Well, it just crosses through like that, right? No problems. Now, someone might say, how would we know that this was going to be an S-curve? And what I would say is you would need to go and take this thing and multiply it out. Does that take a lot of work to multiply out 3 binomials? Yeah. So can I teach you a shortcut? We're only interested in the leading coefficient. That's the very first one. The way we figure that out is by taking this x and multiplying it with that x and multiplying it with that x. What would I get if I do x times x times x? 3x. So that would be x cubed, right? Show me with your hands. What does x cubed look like? No, like the graph. There we go. When it's like this, it's our S curve, right? Is that what it looks like here?
Yeah.
Hey, another thing that's kind of interesting, if you want to be more precise, how would we figure out what the y-intercept is? Well, your y-intercept is the one without any x's. It's just a constant. I would get that by doing 1 times negative 2 times 4. 1 times negative 2 is negative 2, and negative 2 times 4 is negative 8. On your graph, did it have a y-intercept at negative 8? Check real quick on there. Did my graph here? No, because I was just kind of doing a rough sketch. But I should have actually done a y-intercept at negative 8 down here, because if I were to multiply out the constant terms, that's how I figure out what the y-intercept is. So guys, your end goal here is you want to be able to graph these things. So I'm teaching you some tricks for how to do this, okay? So, the x-intercepts or whatever makes the parentheses become 0. If I were to take the x's and multiply them all out, whatever that is, that helps me figure out the shape. go to h of x. Now, h of x has something tricky to it. Just looking at h of x, does anyone see what it is? There's a squared right here. We saw in the other one, all of these multiplicity they were 1. What's going to happen if it's 2? Well, let's do some exploration. First off, let's go to Melissa. Melissa, what would turn each of these parentheses into 0? Let's start with this one. What value of x would take that and make it 0? Good job. Keep going here. And awesome. So I'm going to do h of x over on this graph here. So I've got an x-intercept at -1, at 1, and -2. Now, what I want you guys to do is I want you to graph this on your Desmos, on your Chromebook, and I want you to see how is one different from the other ones. We know something needs to be different because it's used twice. Its multiplicity is 2. How does that show up on the graph? Take a second, graph this, make sure you put a square for the x minus 1, and let's see, how does the graph look different at 1 than it does at -1 and -2? More seconds here. Okay, I'm cutting this short a little bit, but let's talk about it. So guys, looking at Desmos, what is the general shape this is making? Is it an S or a U? This one is a U, that's even. How come, well let's look at this. How many total x's do we have? There's 1 here, but how many are right here? It's squared, so I have 2. So I have 1, 2, 3, 4 x's. So this is x to the 4th. What shape does x to the 4th make? So that's why it's a U. Now let's kind of graph what happens here, okay? And use your Desmos to help me here. So I started up at positive infinity, and we came down, and it crossed through that x-intercept. It crossed through that x-intercept. But then what happened for this one? It bounced. Why did it bounce?
Because it hit twice.
Because the multiplicity is 2. And that is the correct answer. Multiplicity is how many times an intercept is used. If it's used an even number of times, which 2 is even, right? Then instead of crossing at the x-axis, it is going to bounce. Okay? Now, I'm going to teach you a way to remember this. Let's think of this is the club. You guys are all lined up to go in the club. What do you need in order to get to the club? They won't let you in unless you got an ID. Okay. So who's at the door of the club?
The bouncer.
What is the job of the bouncer?
To bounce.
Yeah. So let's say this guy's coming. Let me check his ID, and we're like, you're good. Goes into the club. And this one's going out. And he's good. But then this person's like, hey, we want to let in. And the bouncer's like, where's your ID? And they're like, I left it at home. And so what does he do with them?
Bounce.
Bounces them away and says, get out of here. So our way of remembering this is if your multiplicity is 2 or it's even, you bounce off the x-axis. 1 or 3 or 5 if it's odd, then it's crossing it. Okay. You remember that? All right. Let's do a couple more here. You guys are doing great. Stay with me. We're going to finish off this page and call that good. So let's look at g of x. We're going to kind of do the same thing we've been doing up to this point. Let's start with this one right here. What would make this parenthesis become 0? 1. Now, how many times is that used? It's used twice. I'm going to put a little note here. It has a multiplicity of 2. My board is being slow here. I don't even know what's going on here. Multiplicity of 2. Sorry if you can't read that. My board is really struggling. Okay, so what do we expect to happen at 1? Here's our x-intercept. And what's going to happen there if the multiplicity is 2? If bounds are crossing, if it's used twice, it's going to bounce. Alright? Now, let's go to the second one right here. What is that? What will make that become 0? 2. So we actually have an x-intercept at 2 as well. Okay, what is the multiplicity for that? Okay, what's the multiplicity of this? 2, so what happens? It's going to bounce as well. So we should have an x-intercept at 1 where it bounces, an x-intercept at 2 where it bounces. This last one right here is a little bit tricky, but it's also not too tricky. If I have x all by itself, what does that mean my x-intercept is going to be? It is 0. Good job. Think, what could I plug in to make that become 0? And you would plug in 0, right? So what I have going on here, I want to see if this will help fix it. Throw it away. Is I have an x-intercept at 0, I have an x-intercept at 2, and an x-intercept at 1. Now, bouncing here, it's bouncing here. Is it bouncing at 0? Was it used twice at 0? No, it's only used once, so what should happen at 0? It can cross. Remember, that's your two options, bounce or cross. So, I don't know if this will let me write. Here are 3 x-intercepts. We're going to bounce here, and cross here. Okay, what I want you to do, hurry and graph this on Desmos. And let's check that. Does it bounce at 1 and 2 and cross at 0? You might have to zoom in on this one. It's a little close to the x-axis. All right, guys, did you get that graph? Okay, what shape does this make? Y. How many x's do we have here? 1, 2, 3, 4, 5, because it's squared, right? So that'd be x, 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 x. So this is x to the 5th, which is an S curve. And yeah, what happens is it starts at negative infinity, it crosses at 0, bounces, and then it's right there. All right. This last one, let's just talk about it super fast. What is my 0 here? 0. My x-intercept is 0. Will it bounce or cross? Why will it bounce? Squared is even, okay? What will make this become 0? 1. Is it going to bounce or cross? Cross because it's off. Let's keep going. This would be 2, and it's going to cross there since it's only used once. But here at negative 1, it should bounce, right? How many total x's do we see? 1, before you graph this, and then we'll check to see if it works. So I've got a 0 where it's going to bounce. I've got 1 where it crosses, 2 where it crosses, and -1 where it's going to bounce. So I have this is going to look like this. It's making a U shape, bounce,
Bounce.
bounce,
Then cross, cross.
cross, cross. How would you check that that's right?
Put it in decimal.
There you go. Okay, now the next part of your homework is just talking about finding the roots and stating the multiplicity. So will you guys look at number 9 with me on your homework?
On.
Get out your homework center, look at number 9. It says find all the roots and state what effect the multiplicity has on the roots. So looking at 9, what are my 3 x-intercepts going to be?
-7, 1,
Seven.
-1.
1, -1. Just whatever makes a parentheses become 0. Will it bounce or cross at those points?
Cross, cross, cross.
Why is it cross, cross, cross?
There's no exponent.
There you go, it's all used once. However, if you look at number 11, you have one that's used twice. What would happen there?
Bounce.
Do you have to graph any of these?
No.
No. Now, flip it over, peek ahead to number 17. We didn't talk about this yet too much, but what if it's not into that intercept form?
Then you
Do you
don't.
remember how you get it from standard form to intercept form? Factor. So, try to remember how to do that. We'll review how to do it next time. Now, if you are struggling, what should you come do?
You go to Goldberg and you say, I'm struggling.
Come and get help. When can you come and get help?
Not tomorrow.
Today after school, not tomorrow, come do it. Alright? Alright, thanks guys. You can start cleaning up, but we're not leaving for a minute or two, okay? So let's start getting cleaned up. Good job.